All right, hey, Algebra 2. This is going to be our last lesson. It's going to be Chapter 7, Lesson 5. We are running out of time. We don't have time to get into like the super in-depth problems on here, but we're going to kind of hit the basics, some of the basic skills that you're going to need for pre-cal about solving exponential and solving logarithmic equations. All right, so the first thing that we're going to do is solve an exponential equation. Now, it's similar to where we rewrote as the same base, and that's one of the options, but I'm going to teach you a trick that works for all of them. And it's a lot of calculator work, so make sure you have your calculator available. Also, you have to use your properties in this lesson. So if you have something separated by addition, you put it back together with multiplication. If you have something separated with subtraction, you put it back together as division. And if you have a number out front of the log, you move it back up as an exponent. Or if you have an exponent, you move it back down to the front of the log. And we're going to kind of play around with that and figure out like when we're supposed to do which, okay? All right, so it's just going to say to solve. And we're going to start out with exponential equations, okay? So remember, an exponential is an exponent. Okay, an exponent. Now, hopefully you all can see that. Okay. So we talked about how exponentials and logarithms are opposites of each other. So I'm able to solve an exponential equation by taking logs, okay? Just like addition and subtraction are opposites. Multiplication and division are opposites. Square rooting and squaring are opposites. Exponentials and logarithms are opposites. So in order to get rid of this exponential, I'm going to log both sides, okay? And by logging both sides, that throws in our logarithmic properties, which allows us to isolate the x term. So what I'm going to do here is I'm going to log both sides. So I'm just rewriting both sides with the log. Now, when I do this, the power property comes into play. So the power property says that if you have a logarithm and you have an exponent, you can drop that out front of the log. So that will make that be 3x log 16 equals log 8. And then I'm still trying to isolate the x. So I want to get this 3x by itself. This is actually 3x times log 16. So I'm going to divide both sides by log 16. Okay, so that will cancel those out. And I'll get 3x equals, and then you're going to use your calculator. And we're still going to round to the nearest hundredth. Some of the book says nearest thousandth. Or, nearest thousands. We'll just stick with hundredths. It's okay. So I'm going to do log 16. So log 8, Log 8, close parenthesis, divided by log 16, close parenthesis. Okay. And I got 0.75. And then I still have to get the x by itself. So I divide by 3. And I get x equals 0.25. Now you can check your answers on all these, which is the great thing. So you're going to take 16 to the 3x power. So it's going to be 16. So 16. And then the little caret that's right here. And then we're going to open a parenthesis. 3 times 0.25, close parenthesis. Can you see that? Then hit enter. And I got 8, which is what it should be. All right, we'll do another one. All right. 27 to the 3x equals 81. So pretty much same thing here. This is an exponential. The opposite of exponentials are log. So I'm going to log both sides. So that'll be log of 27 to the 3x equals log of 81. Now with a log, if you have an exponent, you can drop that out front. So that'll become 3x times log 27 equals log of 81. and then I'll divide by log of 27. Those will cancel out, so I'll get 3x equals, and then on my calculator again, log 81, close parenthesis, divided by log of 27, close parenthesis, and I got 1.333333. Okay. You can round to 2 decimal places here, so 1.33, or you can make that 1 1/3. And then I'll divide by 3. So 1.33 divided by 3 is x equals 0.443. So I'm not going to round up. All right, now, since we had to round, that means that this is going to be an 81 that's rounded, okay? So when I go to check it, I'll type 27, the little caret, parenthesis, 3 times 0.44, close parenthesis. And I got 77.5, which is fairly close to 81. If we would have taken that out a few more decimal places, so like if I would have done like 27, and then I did like, what was it, 1.33, what am I typing right now? I can't even think right now. It's like 11 o'clock at night. I'm exhausted. 1.33 divided by 3 times 3. If I wouldn't have rounded it, I would have gotten closer to 81 with an 80. So it's super close. When you round, it's not going to be exactly the right number because of the rounding. And that happens, and that's okay. All right, let's do another one. We can get a couple more practice. You may want to go ahead and pause me and try this one on your own. So I guess the book with all its examples, it really likes 3x's. All right, so pause me and go for this one. All right, so you should have logged both sides. And then dropped your exponent out front. So 3x times log of 15 equals log of 285. And then divide it by log 15. So that's 3x equals. So I'm going to do log 285, close parenthesis, divided by log 15, close parenthesis. And remember, I'm rounding to 2 decimals, so 2.09. And then I'll divide by 3. So 2.09 divided by 3. And I got 0.696, which rounds to about 0.70. All right, check our answer. So 15 caret, parenthesis, 3 times 0.70. And I got 294.97, which is a little bit bigger than 285, but it's still relatively close because of the rounding. The rounding's really going to throw these off because it's an exponent, and just 1 decimal place with an exponent really throws it for a loop. So make sure you're showing your work on these so I can know to count it correct if your rounding's just a little bit off, which isn't a huge deal. All right, one more, and then we'll go for the last type, which are a little bit easier. All right, so 5 to the 2x equals 130. All right, pause me and go for it. So you should have logged both sides, and I don't care when you're logging. If you want to go ahead and drop that out in one step right there just to save yourself a little bit of time, that's okay. Divide by log 5. So that's 2x equals. And if you were to check some of these in the back of the book, they'll round them out to 4 decimal places, which just helps make it a little bit more accurate when you check it. So I got 3.02 divided by 2. And I got x equals 1.51. I'm going to check it. So 5 caret parenthesis 2 times 1.51. And I got 129, which is actually really close to the 130 that it's supposed to equal. So that's great. All right. So the next ones are going to be log equations. And guess what? The opposite of a log is an exponent. So we're going to be able to solve it using an exponential using our relationship. So if you forgot our relationship real quick, the relationship between an exponent and a logarithm. If I have log base 5 of 25 equals 2, you can change that to an exponent by saying 5 to the second power equals 25. That's that relationship that I'm talking about. All right, so let's do log of 2, do log base 5 of 2x equals, I don't know, we'll just do 4. All right, so log base 5 of 2x equals 4. I've got to change this to an exponential, okay, because an exponential is the opposite of logarithm. So I'm going to change this by saying 5 to the 4th power equals 2x. And then 5 to the 4th power is 625 equals 2x. And then I'll divide by 2. And I got 312.5. And you can check it. Using this part right here is what you'll want to check. You'll want to do 2 times this to make sure that it's 625. And it is. All right, let's look at another one. Log of 4x minus 3 equals 2. All right, so you may be looking at this one and like, what the heck is the base? There's no base there. The base of a log that's understood is 10. So if there's nothing written here for the base, we would automatically assume that it's 10. Just like when there's no number in front of a variable, we automatically assume that it's 1. If there's no base on a log, we automatically assume it's 10. All right, so to solve a log equation, I do it to an exponent. I change it to an exponent, so that'll become 10 to the second power equals 4x minus 3. So that's 100 equals 4x minus 3, and then you just solve it like a regular equation. So I'm going to add 3. So that's 103 equals 4x, divide by 4. So 103 divided by 4, that is 25.75. And you can check this one on your calculator here because it's base 10, and your calculator is automatically a base 10. Some of you all have calculators where you can change the base, but majority of calculators don't allow you to change the base, and it's automatically base 10. All right, I'm going to let you all try some here. Let's do log base 4 of 6x equals 3. All right, so pause me and try it. All right, so you should have done 4 to the 3rd power equals 6x. So 4 to the 3rd power, I'll just do it on my calculator because I'm exhausted and I'll get it wrong. 64 equals 6x, and then I'll divide by 6. And I got 10.6 repeating, or you can make it 10.67. I wouldn't write 10.6 repeating, I'd write 10 and 2/3, okay? Because we know 0.6 repeating is 2/3. All right, let's try this one. Log of 2x plus 1 equals 3. All right, pause me and go for it. All right, so you should have put base 10 there. So that's 10 to the 3rd power equals 2x plus 1. So that's 1,000 equals 2x plus 1. Subtract 1. So that's 999 equals 2x. Divide by 2. And I got 499.5, which is right. Let's see. I'm going to do one more just because some of them, people are like, I'm super confused on what to do. I don't know what to do here. All right. Oh, I shouldn't erase that. Okay. So that last problem that we just did, the part that was in the log was in parentheses. On one like this, the log is only of the 6x. This minus 3 is not in parentheses, so it's not part of the log. So you would need to isolate the log first. So that means you need to get this part by itself first. So you'd first have to add 3. Now the other one I did, it was in parentheses to show you that all of it was part of the log. This one, just that 6x is part of the log, so it's the log of 6x minus 3. All right, so then that would be log of 6x equals -1. And then I would put my base 10. So 10 to the -1 equals 6x. 10 to the -1 is not -10. 10 to the -1 is 0.1. Okay, because negative exponents, that's actually where it flips. And then I'll divide by 6. And I got x equals 0.02. All right, so I'm going to give you all just a few homework problems to try a couple of these, and then we're going to just do review problems Monday, and then Tuesday we're going to take a quiz over these last few lessons. So please let me know if you don't understand something. Yep. All right, toodles.